Hello guys, welcome to another LeetCode video. Today we'll be doing this question merge two sorted lists. So basically we're given two lists, list 1 and list 2. Both are sorted in their respective order. We have to merge them to create the final linked list. Alright. Okay. So let's create, sorry, let's create a head equals. Let me address some corner cases first, and I'll call them L1 and L2 for simplicity. If L1 2, if L2, then we return L1. L1, the other one can be null. Answer would be null. If L1 dot was it val less than L2 dot val. Okay. Then so L1 is head dot next equals to L1, else else head dot next equals to L2, and finally we'll be returning head dot next what we returned. Now while L1 not equals to null, and then L2 is also not null. Okay, so L1's val, I have pointed it to the right, so I have the correct start. Now I have to correct. So let's imagine the scenario. L1 is here, L2 is here. So firstly we'll have if L1's val is less than L2's val, then what we'll do is, so L1 should point to node temp equals to L1 dot next. L1 should point to L2. L2, correct? L1 should point to L2. L1's next would L1 would point to L, since L1 is smaller, L1 would point to L2, and L1 would be reset to temp. Then this guy is here. L2 would remain the same, and yeah, then we can do the next iteration now between these two. If this one is smaller, you save this one. You point. That is one problem. So all the small ones would go. Uh, if L1 dot next is, if L1 is smaller than L2, while L1 is smaller than L2, so I need to, if L1 is smaller than L2, I need L1 to keep moving ahead till that element which is the last smaller than L2. Okay, I can't. So since L1 is less than L2, uh, we'll have to keep moving ahead till this condition is valid, right? So while L1 is, if L1 is less than L2, one second. So while L1 dot val is less than L2 dot val, and then L1 dot next not equals to null, and L1 dot next dot val is also less than L2 dot val, I'll do L1 equals to L1 dot next. So I'll keep going ahead till these values are smaller, and finally I my L1 would be at the last element that is smaller than L2. Either after this one there won't be anything, or bigger element will be there. Then what? Then I'll do this. Then I'll save the next one. This could be null. L1's next would be L2, and then L1 would be temp. Now L1 could be null. So this same thing would have to be done with L2. Maybe I can put this in a function. Now let me quickly make a function method for this private uh, list node join. I'll call it list node L1, list node L2. This logic I'll put there. So while L1 keep going next, and finally you save this, and then next is going to that, and we'll return temp, and L1 would be join of L1 comma L2, else L2 would be uh, join of L2 comma L1. So for L2 what will happen is L2 would basically enter here as L1. So it will keep going while L2's val is less than L1's val, and L2's next is not null, and L2's next val is also less than L1 dot val. L2 will keep going ahead. Finally, L2's next will save into temp. The next will return, which will be your new L2. So while this happens, okay. Now the last scenario is what if hmm, what if L2's one of them goes null. Okay, where is my pointer now? It was pointing to L1. Let's say head was pointing to L1, and eventually L1's next is L2. L1 vanishes. Yeah, whichever vanishes, the other list will be preserved with the other one. I'll keep going next, next, next. The final one, I'll save this next. L2 would be null, but this guy's next is this guy, and head is anyways preserved. Head dot next. So another way of doing this is having another current pointer. So if L1's value is smaller than L2's value, current dot next is this one. Otherwise, current dot next is that one. That is much simpler. Okay, head. Let's put this to. Hmm. Yeah, but why do I need to initialize it? Oh, my bad. Yeah, this is the case when one of them is going null. I think I overcomplicated this one again. So current is at dot next. That is your first one. While L1 is not null and L2 is also not null. If dot val is less than L2 dot val, so current, okay, two operations. Current dot, wait a second, it is there, current is there. I don't need this logic also now. I'll have one head, and the current would be copy of head. And then let's start here. If L1's value is less than, then currents next is L1, else currents next is L2, currents next, so L1, L2, L1 is smaller, currents next is L1. Okay, L1 goes to its next. L2 goes to its next. In this case, L1 remains the same. Okay, currents next is L1. L1 goes to its next. L2 remains the same in the next iteration. If this one is smaller, this goes here. If this one is smaller, this next is going to point here. Current is this one. Currents next is L1. This guy's next is L1. Okay, but current has to go to its next, right? Yes, it's L1. And now this guy is smaller. Okay, so current current's next is this. And then this goes here. Current's next is L1. L1 goes to its next. Current goes to its next, so which is here. And then say this one is smaller. Current's next would point to here. L2 would go to its next. This would go here. Finally, return head dot next. Okay. Finally, if L1 equal null, parent dot next equals to L2. If 2 equal null, parent dot next equals to L1. If one list gets exhausted, we have to use the other one. This solution is better. The other one was overly complicated, so I was trying to use the same this thing, same less. Can go ahead, and then this guy's next is this one. Let's save this. Yeah, that solution could have also worked. Let's see. So if this is not null head, I have a new one, and then heads next is also saved to either L1 or L2. Now they are not null if L1 is less than L2. So I think in this one only the last case is remaining. Um, this join method is fine. Verified this. So the case where L1's next becomes null. So it is, let's say this case. 2 is pointing to 2, 3, and 3 is pointing to 4, and L1 is here now. Correct. Now L1's value is, let's say, equal is also considered here. Now L1's this is fine. L1's next is not null. L1's next is null. So what happens is um, temp is null. Okay. Now L1's next is L2. So force next is this guy. L1 goes null. Yeah, that should be fine. Correct. That's what is not making sense. There is one small bug here. Mm, so in this solution, I'm not using so this for linked list both solutions are fine because I'm not creating copies. But for arrays, let's say this solution would be more space saving. Yeah, I just want to find the bug in this one. So if L1 is not null, L2 is not null. L1 is not null. L2 is not null. L2 L1's value is less than, it is not. Points to this one, L2 goes here. Now this one, since value is smaller, L1's value is smaller, next value is also smaller. L1 is L1 dot next. Now value is smaller, next is not null. Next value is not smaller. So it is not smaller. So L1 gets saved, 4 gets saved. L1 is now 4, and this L1 dot next is L2. Okay, now L1 is here, this is here. Okay, now L2 is join, L1 is here, L2 is here. This guy is smaller than this guy. Okay, so that is the confusion. The equal to case problem is, since I'm using the same method, mm, since I'm using the same method, the equal to case is becoming a problem. So let me do this. I have to make sure the equal to case someone is addressing that. Okay, what? Oh shit. Okay, so basically the problem is, in my first case I was checking L1 is less than L2. But then I was assuming the other case would be L2 is less than equals to L1, right? That should happen naturally, but I was using the same method. So here less than was there, and L1, L2 they were getting flipped. So first time I was checking L1 less than L2, second time I was checking L2 less than L1. Equal to case was never getting checked. So now since I have this, in the first round only I'll be checking the equality. So that should take care. It didn't. Same issue. Some issue with equality only. So if L1 is here, L2 is here, L1 is less than L2, less than equals to. So while L1 is less than equal to L2, L1's next value is less than equal to L2, which is not. So once next is L2, L1 goes to 2. L1's value has to be less than, and the next one's value it is greater than you should break. If it is equal, then you can keep going. So next value is also. So 1. Okay, so 1 is less than equals to 1. Next is not null. Next is val is not less. So that breaks. L1 goes here. This guy's next is 1. Why are we missing on the 1? Goes here, and now L1 is not less than equal to L2. So L2 dot join. Still L2 is less than this one. L2 is next is not. Mm, this is the lesser case. the greater than equal to is for L2, and so basically I'm saying L2 will handle equality. All right, cool. Thank you. Bye bye.